All right, welcome back to another fun-filled online geometry class. We're jumping into chapter 4. Chapter 4 is the big proofs chapter. We did some proofs before, and we'll do some proofs after chapter 4, but this one is the big proofs chapter. I'm confident you guys are going to do great because you did so great on the proofs that we did in chapter 3. Just know that we'll be using different tools, and some of the tools that we have been using, we won't really be using all that much. So, 4.1 is just proving figures are congruent. The start thinking part says, what does it mean for figures to be congruent? If you were able to flip back in your notes, or if you remember the definition of congruent, you probably remember it is identical in form. So even though these two figures that we have here, this figure and this figure over here, even though they are flipped, they are still congruent, okay? They could also be different colors and they would still be congruent. They have to be identical in form, not identical in color or in orientation. So here, if we wanted to write a congruent statement, what a congruent statement is talking about how two figures are congruent. Order matters when you're listing your points. So let's say we had this figure, I'm going to start with A and then go A, B, C, D is congruent to figure. Now what you have to do is figure out what corresponds to A. A is here and the same location on the other figure is E, so it's E. B is this location, which on the other one, the corresponding is F, so it's F. C is down here, that right angle. The right angle is G. And H is this, or actually, sorry, D is that one, and H is this one. The cool thing about a congruent statement is that now we know that line segment AB is going to be congruent to line segment EF. Line segment BC is going to correspond to and be congruent to line segment FG. The third point here is C. It is going to be congruent to the third one here, which is G. The points aren't congruent, but if we're talking about the angles, they would be congruent. So this right here is called a congruence statement. It's just stating that two figures are congruent. All right, let's move on. We're going to be jumping around a little bit in these notes. Don't freak out. I make sure I put a lot of extra problems on here, so if we have time, then we cover them, but sometimes it's not really needed. So here, once again, says write a congruence statement. So I would say figure, pick any point, and then either go clockwise or counterclockwise. Let's say HIJK is going to be congruent to figure. Now we have to figure out H corresponds to, it's like L. I corresponds to M. J corresponds to N. And K corresponds to O. That would be a congruent statement, stating that they are congruent. Now, if we wanted to know what the congruent parts were, we could say HI is going to be congruent to what? H and I are the first two here. The first two here are L and M. I and J, IJ is going to be congruent to, that is second and third. Second and third is M and N. And you could go on through this. Like I said, you could also say angle H is going to correspond to and be congruent to angle L. So angle H congruent to angle L. Angle I congruent to angle M. That's covered in this question right here. So let's just go down to this one. Triangle ABC is congruent to M and K. Explain what side angle is congruent to the following. Angle A is the first. The first over here is M. So angle A is congruent to angle M. Angle C, which is the third one, is congruent to the third one over here, angle K. AB is the first two. It is going to be congruent to the first two in the other one, MN. KM, KM is last and first, so it is going to be congruent to last and first, CA. So that's why it's important to write out your congruent statement in the correct order, because now you know a lot about the parts just by reading this. All right, let's keep on going. Now on this one right here, it says write a congruent statement for two sets of congruent triangles. So let's say I had this one. Triangle ACB is going to be congruent to which triangle? ACB. Well, A on this one is between the 1 tick and the 2 ticks. So down here, which one is between the 1 tick and the 2 ticks? D. C is between the 2 ticks and the 1 tick. What's between the 2 ticks and the 1 tick on this one? C again. B is between the 1 tick and the, it looks like 1 tick and 1 tick. So it's between 1 and 1? E. Now the other triangles we can talk about that are congruent would be this one and this one. Okay, but I'm going to stick with just the easier one right here. If we wanted to do this, it would be A, B, D would be congruent to A, B, D, D, E, A. All right. Hopefully the concept of a congruent statement makes sense. Let's go ahead and move on to the next page. Okay, so on this one right here, it says triangle ABC is congruent to triangle ABD. If angle DAB is 48 and C is 60, then what is D? Okay, we are going to skip this one and let's only do this one. So let's see. Let's fill it out. DAB. DAB is 48. 48 goes in there. Now angle C is going to be 60. And they want to know what is angle D. Well, if the two figures are congruent, then their angles are going to be congruent as well. So if we look at this, if this is 60 degrees, then this must be 60 degrees as well. Okay. Now, I want to go back to this previous one over here, and I just want to add something really quickly to our definition. So congruent polygons are going to be polygons. I forgot to write down the definition. Let's go ahead and do that. Polygons whose corresponding angles and sides are congruent. That is the way you find out that they're identical in form. Both the sides and the angles that are corresponding will be congruent. Definition of congruent polygons. We already talked about congruent. I just forgot to write down the definition of congruent polygons. So now we are here. Once again, since C corresponded to D, because C is the last one and D is the last one, I knew that they had to be congruent because the corresponding parts of congruent figures must be congruent. Okay, now let's get into the meat of this lesson. To prove that two triangles are congruent, you need to make sure that all corresponding, and this is for all the figures, but we're just going to look at triangles, all corresponding angles are congruent and all corresponding sides are congruent. You can justify the triangles are congruent by definition of congruent, or definition of congruent polygons if you want. So let's take a look at this. Here is our figure. I have some boxes that I need to check off. Every time I show that an angle is congruent to an angle, I'm going to check off a box. Every time I show a side is congruent to a side, I'm going to check off a box. Okay. Some of the things are given. In this case, we didn't write out given and list things. It's just in the diagram. Okay. So let's try this problem. AB is congruent to ED. That we can see is just given. So I can check one of my boxes for sides. Check. Okay, the next one is going to be that BC is congruent to, BC is the 4, the other 4 is CD. CD. How do I know that? Because both BC and CD both equal 4. So now I can go over and check off another box for an angle or a side being congruent to a side. Now AC is congruent to EC. How do I know that AC is congruent to EC? Well, I'm going to follow along with what they said here. AC equals 6 equals EC. Okay, that was our last box we needed to check off for sides. So now all the sides are checked. Now let's go over to angles. What is the given angle? Well, in this case, they give us 2. Sometimes mathematicians are lazy and efficient, and they go over and put 2 things in a proof. Angle A is congruent to, that's one arc. What's the one that has one arc? E. And I can call them angle A and angle E because there's no confusing what angle is A. It's not like there's 3 different angle A's. What is the other angle that they tell us is congruent? Angle B is congruent to angle that's a double arc. The other double arc is angle D. And that's given. So I can go over and check off 2 boxes. Now, if I wanted to figure out the last angle, because I know I need one more angle before I can be done. If I look at this figure, what is an angle of one triangle that's congruent to another angle, and what would be our justification? Well, this is a fill in the blank because we're baby stepping you in. We have BCA. BCA must be congruent to DCE. DCE. Why is that angle and this angle congruent? Vertical angles theorem, and you'd be able to find that inside of the geometry toolbox. Vertical angles theorem. Now we have checked off all boxes for angles, all boxes for sides. So now we can just say the 2 triangles are congruent by def of congruent triangles. And there we go. That's what we're going to be doing for this section. Make sure you've checked off all boxes for angles, all boxes for sides, and then you can just finish your proof like this. Oh, since all the parts are congruent, they must be congruent. Okay, go to the next page. So let's say we were looking at this. If I had to, we're not going to write out a full proof. Let's just see if we have enough to be able to say that these are congruent, because that's what it's asking. Are they congruent? Well, we know that this is congruent to that, so I can check off a box for a side. I know that, oh, this is when the reflexive property pops in. Look at this. This side is shared by both, so obviously it must be congruent. The side for that one must be congruent to the side for this triangle because it's a shared side. So by the reflexive property, those are congruent. If we go to angles, we have an angle is congruent to its corresponding, check. You have 2 right angles. If you looked at your geometry toolbox, you would see it says that all right angles are congruent. So if we were doing this proof, we would state that they were right, given, and then we would say they're congruent because all right angles are congruent. Okay, at this point, don't see any other angles. And it's not like they told us that this was a midpoint or something, so nope. Not enough information. Not enough information. All right, now we're going to come up. Let me go ahead and show you this. We have this little thing called the third angles theorem. What the third angles theorem says is if you know that 2 sets of angles are congruent to they're corresponding, then the thirds must be congruent. We have a little proof here. So if B was congruent to E and A was congruent to D, then we would know C has to be congruent to F. And here's the little proof. A is congruent to D, B is congruent to E. How do we know that? It's just given. Therefore, they are equal. What is the thing in our geometry toolbox that says if they're congruent, then they are equal? Def of congruence. The next one says that all the angles of a triangle must add up to be 180 degrees. Well, if we should probably just bring up, let me see if I can get my geometry toolbox real quick. Geometry toolbox, and recent, sorry, there we go. All right, geometry toolbox here. If we looked in here, what is it that says that all the angles of a triangle, oh, look at this. Triangle angle sum theorem says interior angles add up to be 180 degrees. So what I can do now is I can say this is the triangle angle sum theorem. Triangle angle sum theorem. If they both equal 180, what tells you that you're allowed to go over and set them equal to one another? What tells you you're allowed to erase the 180 and put what 180 equals? Substitution. Next, it looks like what they did was they erased a B and put an E. That's really weird. Why are they allowed to erase a B and put an E? And why are they allowed to erase, and I think that's all they did. They erased a B and put an E. Why are they allowed to do that? Oh, substitution again. And then what did they do? They erased an E from that side, or subtracted it from that side and subtracted it from that side. They subtracted the D and they subtracted the D. What tells you you're allowed to subtract the same thing on both sides? Subtraction, prop of equality. And then lastly, if they are equal, they are congruent. That's another definition of congruence. You might be asking, what in the heck are you doing, Gallagher? What is this proof? This is really weird. Whenever we use something in math, we really should prove it first to make sure it's true. It's like if you're having some argument, political argument with a friend or something, before you go over and state it as a reason in your justification for something, you'd want to go over and actually fact check it and make sure that it's right. So this was us going through a process to be able to show that if two sets of angles are congruent, then the third ones have to be congruent. This was the formal mathematical proof. Could have also gone over and said, this is 20. This would just be an example though. 20, 100, and 100. Let's say those were 120. That means you have 60 left over. If these are 120, then you must also have 60 left over. So that's the concept, but this is a single case, one case, and this is infinitely many cases. So now in a proof, if we want to, we can use the third angles theorem. Like right here, since we already knew two pairs of angles were congruent, we could have said that this one was congruent to this one by the third angles theorem. We still don't know that, so it's still a no. All right, let's keep on going. All right, let's see if we could do this proof. Are we going to be able to check off our boxes? I can check off one box because that's congruent to that. Okay, let's see. We can check off another box because that one's congruent to that one, so that's two of the S boxes. That's congruent to that, so we can check off all of the S boxes, and that's all given, so that's going to be the easy part of the proof. Remember, I always tell you guys to think through your proof before you actually write it down. Now, A is congruent to D, so I'll be able to check off one box for angles. Ooh, we got vertical angles. I told you we're going to use that a lot. Vertical angles is another A box, and then the third angles theorem would let us check off the last, and we would be able to finish our proof. So let's go ahead and write that down. So we know AE is congruent to DC. We know EB is congruent to CB. And we know that BA is congruent to ED. That is because it is given. And I can check, check, check. Now we got to move on to angles. I know angle A is congruent to angle D because it's given as well. Should also write down the word given. Now, vertical angles theorem was my other one. I can't just call this angle B right here because there's too many angle B's. So I have to call it angle ABE is congruent to angle CBD. Vertical angles theorem. Check. And then lastly, I can say angle E is congruent to angle C by the third angles theorem. Now you could put that in your geometry toolbox. I'm going to tell you soon it's going to become obsolete, meaning you're not going to use it. You really only use it for this section. So if you want to put it in the geometry toolbox, go ahead, but you don't have to. Now that I have an S, an S, and an S, and an A, and an A, and an A, I've covered all of those, and I can go over and say the whole entire triangle AEB is congruent to triangle DCB by definition of congruent triangles. The concept here for what we're doing in this section is, let's say you had two trucks and you were pretty sure they were congruent trucks, but you weren't 100% sure. One way you could do this is check that wheel and check this wheel and make sure they're congruent. Check that wheel and check that wheel, make sure they're congruent. Check the windshield, make sure they're congruent. Check the headlights, make sure they're congruent. Check the taillights, and you would check every single aspect of the truck. And once you've checked off a box for every single aspect of both of the trucks, then you could say they are congruent by definition of congruent trucks, because you have checked every single piece. It was time intensive, and maybe there's a different way of doing it that wouldn't take so long, but this is the only way we know now. Just check every single part. Let's take a look at one more proof, and then we are done. So this one says we're not allowed to use the third angles theorem. Punks, not letting us use all of our tools. It's like doing a construction project, them saying you can't use a hammer. Okay, well, I'm going to have to figure out some other way to do the same thing a hammer does, but with a different tool. So this is the diagram to the right. Everything that is in the diagram, we are allowed to use. So it looks like we have a side congruent to a side. I can check that off. Another side, a side congruent to a side. Check that box. Another side congruent to another side because of two tick, and then the third sides. So we are able to check off all of our boxes for sides just by givens. They also give us an angle is congruent to an angle. So I could check off a box for angles. What else? Ooh, vertical angles theorem. We could do that's congruent to that by the vertical angles theorem. Then it says that we're not allowed to use the third angles theorem. Well, I need to check off, what's another way I could show that this was congruent to this? Well, if we knew that these lines were parallel and that was a transversal, this would be congruent to that by alternate interior angles theorem. So we just need to figure out a way to show that those are congruent. This one's going to be a hard proof. This is how we're going to do it. We're going to state that AB is congruent to DE. Great. We know that AC is congruent to CE. Cool. And we know DC is congruent to CB, all because it is given. I've now checked my boxes for my sides. Cool. Then we know that angle B is congruent to angle D, given. Oh, I guess we are going to use stuff from last chapter. Check out this now. If we go over and know that those angles are congruent, that's like this. We know that this angle is congruent to that angle. Then we know the lines are parallel. So we could say AB is parallel to DE by converse of AIA. Now that we know these are parallel, I can go over and say angle E is congruent to angle A by the actual alternate interior angles theorem, because now we know that the lines are parallel. Lastly, angle ACB must be congruent to angle DCE by vertical angles theorem. And finally, we can say triangle ACB is congruent to triangle ECD. And that would be by definition of congruent triangles. Super time-staking, a little glimpse into the future. You know mathematicians are crazy, lazy, and efficient. Do you think you would just go over and check every single piece? For example, with the whole truck example, isn't there got to be an easier way to figure out if the trucks are congruent? Maybe look at the make, model, and year rather than going over and looking at every single aspect of the truck. In the future sections, we might find out some shortcuts, but as of right now, we have to check all of the aspects of the triangles, all angles and all sides. And if all angles are congruent to all angles and all sides are congruent to all sides of the two corresponding triangles, then they must be congruent by definition. Now let's just fill out this wrap up. To prove two triangles are congruent, you need to show that all corresponding angles are congruent in all corresponding sides. So at our level right now, we have to check every piece. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent by the third angles theorem. Remember, we're not going to use this one all that much, but a little bit. When you write a congruent statement, you must be careful with the order that you list the points. Okay, you say triangle ABC is congruent to triangle DEF. That is saying that A is corresponding to D, B is corresponding to E, and C is corresponding to F. If that's not the case, then you need to have the correct order. And that's it. I hope that made sense. The last proof was pretty challenging. Just know that at our level right now, we're checking all aspects of the two figures to see if they're all congruent, and if all pieces are congruent, then the figures must be congruent. Thanks for watching.